Hi guys! Today we're going to be working on finding definite integrals and how those relate to area. So in the past, in our past lessons, we've learned about something called an indefinite integral. Well, today we're going to be talking about a definite integral. And so definite means like finite, like there's a beginning, there's a solid start and a solid end. So that's what we mean by definite. And then we'll also see how area relates to a definite integral. So the first thing you need to know is how I want you to think of a definite integral. I want you to think of it as the area between the function f of x, the x-axis, and the vertical lines x equals a and x equals b. So here I have the function, the x-axis, and then the vertical lines x equals a and x equals b. And I read this expression out loud as the definite integral from x equals a to x equals b of f of x dx. And so these, you'll see numbers right here in for a and b. These numbers are called the limits of integration. And the f of x part is what we call our integrand. So let's draw a picture. I have this function. We'll label this function f of x. And let's say I ask you to find the definite integral from x equals 2 to x equals 10 of f of x dx. So the way that this is written, this means start at x equals 2. So I'm going to start at the line x equals 2. Try to draw a vertical line right here. I'm going to stop at x equals 10. So find x equals 10, draw a line here. And I'm going to find the area between these two lines, the x-axis and the curve. So that's what we mean by the definite integral. It's going to be represented by that area. Now we do have to be careful on finding this number because in general we think of areas as always being positive. However, definite integrals can be positive or negative. So I could evaluate this if I didn't have this picture, and I could get either a positive value or a negative value depending on what's happening. So I have to be careful for a couple of times. And I'll show you a couple pictures here. So first, if you have an area that's going to be above the x-axis, we'll think of that area as being positive because the height of the curve would be positive here. And then an area below the x-axis we'll think of as being negative. And then above this area would be positive, as long as we're reading this from A to B. Now next class we'll switch that up, but for right now, consider the area to be positive if it's above the x-axis, negative if it's below. So here's another picture too, something you'll see later on today. Sometimes you'll have to be given some of these numbers because we don't really quite know how to find this area yet, a perfect number for it. So you'll be given some of these measurements if we can't find our areas. But on this one, let's take a look at it. The function f is shown below. What's the value of the definite integral from x equals 0 to x equals 9 of f of x dx? So first of all, let's figure out what we're trying to find the definite integral of. Let me see, x equals 0 is this line right here. X equals 9 is right here. And so it looks like I'm trying to find the area between the x-axis, these two lines, and this function. So when I look at this, I see a weird shape, but then when I look a little bit closer, I can see that, oh, this part right here is a triangle. And I know that the area of a triangle is 1/2 base times height. So I could find the area of this triangle by doing 1/2. The base looks like it would be 1, 2, 3 times 3. And the height is 4. So 1/2 times 3 times 4 would be 12 divided by 2, 6. So this area right here, this green triangle, is 6. So I'll label it 6. Then I look at this second region, and I see a trapezoid. Maybe you saw a trapezoid too. Or maybe you said, okay, well, I don't love trapezoids. Maybe you said, okay, well, if I draw a line right here, I have a rectangle and then a leftover triangle, a rectangle and triangle. Is that cool? Yeah, that's cool. You can do a rectangle and triangle too. That's totally fine. But I'm going to do a trapezoid. And I know that the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So the area of this trapezoid is 1/2. The base 1 would be the bases are always parallel. So from 3 to 9 would be 6, plus from 6 to 9 would be 3. And the height is perpendicular to the base. So this height is 4. So the area would be 1/2 times 9 times 4. That's 1/2, 36. So this area is 18. So then if I want to find the value of the integral from 0 to 9 of f of x dx, I can add 6 plus 18 because they are both above the x-axis to get 24. So the definite integral from 0 to 9 of f of x dx ends up being 24. Sometimes you have a function that is both above the x-axis and below the x-axis. So for this one, we'll be looking at the definite integral from -2 to 6. I'll draw a vertical line here from -2 to 6. And I see, oh, all of this is area below the x-axis. So I might want to divide it up into smaller regions. Let's see, right here, I see a triangle for the first area. And then maybe another trapezoid, another trapezoid. So first triangle, it's right here. So that area equals 1/2 base times height. So 1/2 times, that goes to -2, so 2 for the base. Height looks like it's 3. 2 times 3. 1/2 times 2 times 3 is 1/2 times 6, which is 3. So the area of this rectangle is 3. Not rectangle, triangle, 3. Then this middle section kind of looks like it might be a rectangle. However, notice this line is slanted, so we do have to be careful here. This is actually a trapezoid. The formula for the trapezoid is 1/2 base 1 plus base 2 times the height. So area would be 1/2. Base 1 and base 2 are the parallel lines. So this time the bases are vertical. So let's see, it looks like this base would be 3. This base is 4. And the height's always perpendicular to the bases. So from -1 to 4 would be 5. So the area of that trapezoid is 1/2 times 7 times 5. Looks like 35 over 2, and 35 divided by 2, 17.5. Then for this last one, I'll find the area of this trapezoid. Whoops, let me make that blue. This trapezoid. So I substitute 4 for one base, 6 for another base, and the height of 2 into the formula. And so I get that the area for this blue trapezoid to be 10. So if I'm trying to find the definite integral from -2 to 6 of f of x dx, -2 to 6 of f of x dx, I take each area, but I also have to consider that all of these areas are below the x-axis. So -3 plus, red one, -17.5 plus -10 will be the value of the definite integral. So -30.5. Sometimes you'll have the integral from -9 to 2. So this whole area, and remember, it's the area between that function and the x-axis. So we're looking for all of this area. Now I can divide this up into a rectangle right there, a rectangle right here, and then here it would be a rectangle, but then I'm going to take out a semicircle. So let's find those areas. First, a rectangle has an area, let's see, 1, 2, 3, 4 times 3. This rectangle has an area of 12. Second rectangle, 1, 2, 3 by 1, 2, 3, that has an area of 9. And then for this piece, I'm going to take the area of the rectangle and subtract the area of the semicircle. So area rectangle minus area of the semicircle. So the area of the rectangle looks like it is 1, 2, 3, 4 times 1, 2, 4 times 3. Four times 3 minus 1/2 pi r squared. So the formula for the area of a circle is pi r squared divided by 2, so 1/2. So 12 minus 1/2 pi, the radius would be, looks like it's 1, 2. So it looks like it would be 12 minus, that's 4 over 2, 2 pi. So then I go and add all these up to find the definite integral from -9 to 2 of f of x dx equals, just remember to treat all these areas as negative. -12 plus, now I have this whole thing needs to be negative. So minus 12 minus 2 pi, and then plus -9. So it'd be -12 minus 12 plus 2 pi minus 9. Looks like it all simplifies to 2 pi minus 9. Sometimes you'll have problems like this with the curvy regions where you can't use your geometry formulas to find the area, but they'll tell you some information. The area of region A is 17. Now, since A is below the x-axis, I'm going to go ahead and label it -17. The area of region B is 13, below the x-axis, 13. The area of region C is also 13, so -13. And they want to know what is the value of the definite integral from -8 until 6. So to find that, I'll add up -17 plus -13. Oh, that was positive 13 because it's above the x-axis. Plus 13. Looks like I get -17. Then you'll also have questions like this where they ask you to determine which of the integrals is greater than all three. And so you're going to have to figure out which one would have the bigger area. Now, I don't have numbers for my areas, but I can estimate. So the first one, integral from -4 to 8, would be from -4 to +8. Ooh, let's see, there's a little bit of negative area right here, but then there's a lot of positive area. So I'm thinking this is a positive number. Okay, maybe that'll be enough information. From -8 to +5, it's a little bit of positive. Now these two looks like about the same amount on the top and the bottom. So those look like they cancel out, but this looks like it's positive as well. So I have to come back and compare those two in a minute. From 0 to -8, or from -8 to 0, looks like that's from -8 to 0 is this region plus that region, which looks like we have a positive region and a negative region that are both about the same size. Something in this value would be 0. And then the region from 0, from -4 to 0 is right here, which is all negative, so negative. All right, so I can eliminate these two. Now I just have to compare and see which one of these looks bigger. So from -4 to 8, or from 5 to -8. So -4 to 8 would be this part, and this part, and then this part. And then from -5, or from -8 to 5 would be this part until here. I'm going to think that -8 to 5 is this part. There's a lot of positive, not much negative. And then from -4 to 8, I've got two sections of positive. I'm going to think from -8 to 5. I think this one's probably the larger one.